Imagine standing on a beach here on Earth. The sun warms your face. Waves crash against the sand, a rhythmic sound that has played for billions of years. You see the vast blue ocean stretching to the horizon, full of life and motion. It is a familiar and beautiful scene, a world teeming with water. Now let's travel across the vastness of space to our neighbor Mars. Today, Mars is a world of red dust and silent, cold deserts. It is a planet that appears utterly dry, a stark contrast to our vibrant blue marble. The wind whispers across its empty plains, carrying dust from one crater to another. It seems like a place where an ocean could never have existed. But what if I told you that this was not always the case? What if billions of years ago you could have stood on a Martian shore and watched waves lapping against red sand? Imagine a sky, perhaps a faint pink or a soft orange, with two small moons, Phobos and Deimos, hanging like distant diamonds. Below, a great northern ocean might have shimmered under a younger, fainter sun. This is not just a dream or a science fiction story. This is a real possibility that scientists are exploring, a tantalizing clue from the deep past of another world. The story of Mars might be a story of two shores, the vibrant living ones of Earth, and the long-lost phantom ones of Mars. The journey to uncover this hidden history is one of the greatest adventures of our time. It requires us to look beyond what we can see on the surface. We must become cosmic detectives, piecing together clues that are billions of years old. The red dust of Mars covers a multitude of secrets, a geological storybook waiting to be read. Each grain of sand, each rock formation, and each deep canyon holds a piece of the puzzle. The idea of a Martian ocean forces us to ask a profound question. Could a planet that is now so barren and cold have once been a world much more like our own? A world that was once wet and maybe, just maybe, alive. This quest transforms Mars from a simple red dot in our night sky into a place of immense possibility. It becomes a destination not just for our robotic explorers but for our imaginations. We look at its polar ice caps, its winding river channels carved into the rock, and we wonder. We are driven by an innate human curiosity, a desire to know our place in the universe and to find out if we are alone. The search for ancient water on Mars is the first step on that grand voyage of discovery. It's a search that takes us from the familiar beaches of Earth to the mysterious buried coastlines of a world next door, a world that may hold the secret to life beyond our own. So, why are we so obsessed with water? Why do our rovers and orbiters spend years sniffing around Mars for the slightest hint of H2O? The answer is simple, yet it is one of the most profound truths we know. Here on Earth, wherever we find water, we find life. From the deepest, darkest trenches of the ocean to the steaming hot springs of volcanic vents, life has found a way to thrive in water. It is the universal solvent, the medium in which the chemistry of life unfolds. The cells in your body are mostly water. The first life on our planet began in the primordial soup of its ancient oceans. Water is the key ingredient in the recipe for life as we know it. This fundamental connection between water and life is our guiding star in the search for extraterrestrial biology. When we send our robotic emissaries to other worlds, we are following a simple strategy. Follow the water. If a planet or moon has, or once had, liquid water, then it had one of the most critical ingredients for life to begin. Mars is particularly exciting because we see so much evidence that water was once abundant there. We see vast canyons that look like they were carved by powerful rivers. We see delta fans where those rivers might have emptied into larger lakes or seas. The planet is covered in these tantalizing ghosts of a wetter past. Think of it like being a detective arriving at a scene. You see signs that something significant happened long ago. On Mars, the dry riverbeds are like footprints leading us toward a bigger story. Finding evidence of a vast ancient ocean would be like discovering the centerpiece of that story. It would mean that Mars, for a long period in its history, had a stable environment with a large body of liquid water on its surface. This would dramatically increase the chances that life could have emerged there, independently from life on Earth. The search for water is not just a geological survey, it is a profound astrobiological quest. And so, every drop of frozen water in the polar caps, every hydrated mineral found in the soil, and every hint of an underground reservoir becomes a beacon of hope. It tells us that Mars was not always the desolate world we see today. It had the potential for life. This is why scientists get so excited about discoveries related to water. It's more than just chemistry and geology, it's about our own origins and our place in the cosmos. Are we a singular miracle, or is life a common outcome when the conditions are right? Mars, our dusty red neighbor, may hold the answer, and that answer begins with the search for its lost water. To solve the mystery of Mars's lost water, we need to send our best detectives. In 2021, a new player arrived on the Martian scene, ready to take on the case. China's ambitious Tianwen-1 mission, whose name means questions to heaven, was a three-part cosmic fleet, media group, Tianwen-1 spacecraft, animation showing orbiter, lander and rover, Oxstock, distribute equally, an orbiter to circle the planet from above, a lander to carry precious cargo to the surface, and a rover to explore the ground. The rover was named Zhurong, after the ancient Chinese god of fire. This fire dragon was tasked with a monumental job, to explore a region of Mars that no one had ever visited on the ground before, a place called Utopia Planitia, or the Nowhere Land Plain. This landing site was chosen for a very specific and exciting reason. Utopia Planitia is a massive, flat basin in Mars's northern hemisphere. From orbit, it looks suspiciously like an ancient seabed. Scientists believe that if Mars ever had a great northern ocean, this vast plain would have been right at the bottom of it. It is one of the smoothest, lowest places on the entire planet. Landing here was like landing on what might have been the abyssal plain of a long-vanished Martian sea. By exploring this area, Zhurong had the chance to find direct evidence of that ocean, something that had eluded previous missions that landed in other locations. The journey and landing were a marvel of engineering. The Tianwen-1 spacecraft traveled for nearly 7 months across hundreds of millions of kilometers of space. Once it arrived at Mars, the orbiter began mapping the surface, carefully selecting the perfect spot for Zhurong to touch down. Then came the hard part. The 7 minutes of terror of entering the atmosphere, deploying a parachute, firing rockets, and gently lowering the lander and rover to the ground. On May 15, 2021, Zhurong landed safely, making China only the second country to successfully operate a rover on the surface of Mars. The Fire Dragon had arrived in the land of nowhere. With its wheels firmly on the red ground, Zhurong began its mission. Its primary goals were to study the local geology, analyze the composition of the soil and rocks, search for water ice, and investigate the Martian climate. But underneath all these specific tasks was one overarching question. Was this place once underwater? Was Utopia Planitia truly the floor of an ancient ocean? Zhurong was perfectly positioned to find out. It was a robotic explorer standing at the heart of one of Mars's greatest mysteries, ready to use its advanced tools to read the story written in the rocks and buried beneath the dust. The world watched, waiting to see what secrets the Fire Dragon would uncover. To find the secrets of a lost ocean, you can't just look at the surface. Billions of years of dust storms and meteorite impacts can hide the evidence. You have to look deeper. The Zhurong rover was equipped with a special tool that allowed it to do just that. It carried a ground-penetrating radar, or GPR, an instrument that works a bit like an ultrasound for a planet. The radar sends radio waves down into the ground. These waves travel through the subsurface materials like soil and rock, and then bounce back when they hit a different type of layer. It's kind of like shouting into a canyon and listening for the echoes. By analyzing how these radio waves bounce back, scientists can create a picture of what lies beneath the rover's wheels, deep underground. Different materials reflect the radar signals in different ways. For example, a layer of solid bedrock will look very different from a layer of loose sand or, most excitingly, a layer of water ice. Zhurong's radar was incredibly powerful, capable of peering hundreds of feet down into the Martian crust. As the rover drove across the plains of Utopia Planitia, it was constantly scanning the world below, building a map of the hidden geology, layer by layer. This was our first high-resolution look into the subsurface of this specific region. Imagine Zhurong as a cosmic archaeologist, carefully brushing away the dust of ages, not with a brush, but with radio waves. Each layer it detected was like a page in Mars's history book. The deepest layers would be the oldest, telling a story from the planet's distant past. Scientists were particularly interested in looking for patterns that might suggest the presence of water. For instance, sediments deposited by water often form smooth horizontal layers. Finding such patterns deep underground would be a powerful clue that a large body of water, like a lake or an ocean, was once present in that location for a very long time. The rover slowly and methodically made its way across the plain, its radar humming silently as it worked. The data it collected was beamed back across the vastness of space to scientists on Earth. They eagerly processed the information, translating the faint radar echoes into a visual map of the Martian underworld. They were not just looking for rocks and dirt. They were looking for the ghost of an ocean. They were searching for the telltale signs of a shoreline, a beach, or a seabed that had been buried for billions of years, waiting for a visitor from another world to finally reveal its existence. As the data from Zhurong's radar poured in, scientists began to see something extraordinary. Deep beneath the surface of Utopia Planitia, the radar images revealed distinct, buried layers. These were not just random jumbles of rock. The patterns were structured and widespread, suggesting a large-scale geological process had formed them. The most remarkable finding was the evidence of what appeared to be ancient shorelines, buried under meters of dust and volcanic rock. The rover had found the echoes of a lost coast hidden from view for eons. It was a groundbreaking discovery, a smoking gun in the search for Mars's oceans. The radar data showed different layers that scientists interpret as the result of rising and falling sea levels. Imagine a beach where the tide comes in and goes out. Over thousands of years, this process leaves behind distinct layers of sand and sediment. Zhurong's radar seems to have found a similar pattern on a much grander and much older scale. The data suggests that there were at least 2 major flooding events in this region in Mars's deep past. An ancient ocean may have advanced and then retreated, leaving behind a geological signature that Zhurong was able to detect billions of years later. This was the most direct evidence yet of a Martian sea in this location. What makes this discovery so powerful is where it was found. Previous missions had seen features from orbit that looked like shorelines, but there was always debate. Some argued they could have been formed by volcanic activity or other geological processes. But Zhurong was on the ground, in the very basin where the ocean was thought to have been. Its radar peered directly into the subsurface and found layered sediments that are best explained by the action of a large body of water. It was like finding seashells buried deep in the soil of a desert, a clear sign that the sea was once there. This finding helps rewrite the story of early Mars. It suggests that the northern plains were indeed home to a liquid water ocean. This wasn't just a small lake or a temporary flood. The scale of the features Zhurong detected points to a vast, long-lasting body of water. The Fire Dragon rover, exploring the Nowhere Land plain, had found the shoreline of a forgotten world. This transforms our understanding of the Martian past, making it seem much more Earth-like than we previously knew for certain. The silent red planet once had a dynamic watery coast, a place where the chemistry of life could have potentially sparked into existence. Zhurong's discovery of buried ocean sediments adds a crucial piece to a very complex puzzle: the Great Martian Climate Mystery. For decades, scientists have been faced with a paradox. We see overwhelming evidence that liquid water once flowed freely on Mars: the canyons, the deltas, the dry lake beds, and now Zhurong's buried shorelines. All of this points to a planet that was once warm enough and had a thick enough atmosphere to support liquid water on its surface. Yet, our models of the early solar system suggest that the sun was much fainter back then, providing less heat to all the planets, including Mars. This is the faint young sun paradox. How could Mars have been warm and wet under a sun that was perhaps 30% dimmer than it is today? To keep water from freezing, Mars would have needed a powerful greenhouse effect, far stronger than Earth's. This would require a very thick atmosphere rich in gases like carbon dioxide. However, we haven't yet found the geological evidence for the massive carbonate rock deposits that such an atmosphere should have left behind when it disappeared. So we have a mystery. The evidence on the ground screams warm and wet, while our climate models whisper cold and frozen. Zhurong's findings intensify this debate. By providing strong evidence for a northern ocean, the discovery makes the case for a warmer, wetter past even more compelling. It's no longer just about explaining a few rivers, it's about explaining a whole ocean. This forces scientists to rethink their models of the ancient Martian climate. Perhaps the atmosphere had other, more potent greenhouse gases that we haven't considered. Maybe massive volcanic eruptions periodically warmed the planet for long enough periods to allow oceans to form and life to take hold before the planet froze again. The rover's data suggests the flooding events in Utopia Planitia happened in the late Hesperian to early Amazonian periods of Martian history. This is relatively recent in geological terms, making the climate problem even trickier. It means Mars may have had liquid water on a massive scale later in its history than many models predicted. Zhurong's discovery doesn't solve the climate paradox, but it sharpens the question and eliminates some possibilities. It tells us that somehow, Mars did manage to support a northern ocean, and now it is up to us to figure out how that was possible under a faint young sun. The discoveries made by the Zhurong rover do not close the book on Mars. They open a brand new, thrilling chapter. We now have the strongest evidence to date that a vast ocean once existed in the planet's northern hemisphere. This profound realization leaves us with a cascade of new and urgent questions that will drive the future of Mars exploration. The first and most exciting question is, if there was an ocean, was there life? A stable, long-lived body of water provides a perfect potential cradle for life to emerge and evolve. The buried shorelines of Utopia Planitia are now prime targets for future missions designed to search for biosignatures, the chemical fossils of ancient life. Another great mystery we must now confront is, where did all that water go? If Mars had an ocean, what happened to it? We know some of it is locked away as ice in the polar caps and buried underground. But to have an ocean, Mars also needed a thick atmosphere, which it has since lost. Scientists believe the planet's weak gravity and the loss of its protective magnetic field allowed the solar wind, a stream of charged particles from the sun, to slowly strip the atmosphere away over billions of years. As the atmosphere thinned, the pressure dropped, and the water either boiled away into space or froze solid. Understanding this process is crucial for understanding how a habitable world can die. So what comes next? The quest to understand Mars is a global effort. Future missions like the Mars Sample Return Campaign being planned by NASA and ESA aim to bring pieces of Mars back to Earth. Imagine analyzing a rock from an ancient Martian shoreline in our most advanced laboratories. Such a sample could contain definitive proof of past life. New orbiters will continue to map the planet with ever more powerful instruments, and the next generation of rovers will be equipped with drills that can dig even deeper than Zhurong's radar could see, perhaps reaching actual deposits of ancient water ice or briny mud. Zhurong's legacy is a powerful reminder that there are still incredible discoveries waiting for us in our own solar system. Mars is not just a dusty, dead planet, it is a dynamic world with a complex and mysterious history that we are only just beginning to unravel. Each new mission, each new discovery, brings us closer to answering some of humanity's oldest questions. Are we alone? Could life exist on other worlds? As we continue to explore the Red Planet, we are not just learning about Mars. We are learning about the nature of planets, the conditions for life, and our own place in the grand cosmic story. The journey has just begun.